video issue, no, please let us know. No, right? So everything is fine. Okay, great, great. Okay, right, fine. So we are starting with this question now. So this question is from redox reactions. Okay, so redox reaction. What exactly a redox reaction? It is simple, like a shortcut, no? Redox. What is it? Redox. So it is basically a combination of two But what is reduction? What is oxidation? Can anyone tell me, what is reduction? Yes, in redox reaction, both will occur. Okay. I'm getting different definitions: addition of hydrogen, removal of oxidation, gain of electrons. Loss of electrons is not true. Okay, gain of electrons, fine. Okay, fine. All those definitions are true. Okay, but let me tell you one more simple way of finding reduction and oxidation. Yes, gain of electrons, that's true. Okay, so I'll write in very simple manner. Okay, see, a reduction actually means decrease in oxidation number. Very simple way we can define decrease in oxidation number. But what is oxidation number? Again, no? So reduction definition is fine, decrease in oxidation number. But what is it? Okay, so what is oxidation number? So the most important topic of chemistry today. Okay, what is oxidation number? Okay, it is just hypothetical charge. Okay, it is just hypothetical charge, because every molecule, it cannot be divided into ions. Let me give you a very simple example. H2O. H2O I can't write like this. H plus O minus 2. This can't give like this. Will it give like this? No. H2O, it can't give H2, H plus and O minus 2. No, this will not give. And look at another example. So let me give you CH4. CH4 can't give C plus 4 or plus 4H minus. No, it is not possible. Correct? So hypothetical charge. Okay, so listen carefully here. It is just a hypothetical charge present an element when other elements removed as ions. Okay, when you remove other elements as ions, so whatever the leftover charge on that particular element is oxidation number. So we'll do more examples. Let me give you same H2O. We are not breaking into ions. This is just hypothetical. So if I break this bond, but H2O will not give H plus, not readily. Okay, the H plus given by H2O is very small. So that is why it can't conduct electricity. So everybody knows, right? Water is very poor conductor. Okay, fine. So let us see this. If I break this bond, H is plus. Okay, sir, why H is plus? Do you know why it is H plus? Why I'm breaking H plus? Why not H minus? Because there is a difference in electronegativity, right? Oxygen is electronegative element, but hydrogen is electropositive compared to oxygen. So H will break it as plus 1. So what is the charge on oxygen now? If I break H plus, so there is minus 1. Okay. Now I'll break all other atoms, right? So I'll break the next atom, hypothetical breaking. Okay, so this will get, this is again +1, and this will increase further charge, right? So this will be now how much? -1. So what is the charge on oxygen? This is just hypothetical charge. We are not saying it is giving O -2. Okay, it is just hypothetical charge. So charge on oxygen, charge on oxygen. So this is -2 in water. Charge on hydrogen, how much it is? Sir, we have two hydrogen. Which hydrogen you're asking about? So I'm asking overall hydrogen. Total charge is +2, +1 on each hydrogen, and there are two hydrogens, right? So +2 by 2, average charge, how much it is? +2 total charge by 2 atoms, so it is +1. Hydrogen is +1. So oxidation number is basically charge, hypothetical charge. So hydrogen it is +1, oxygen it is -2. Now if I take another example, so sodium hydride. So what is the charge in sodium? Can anybody tell me now? What is the charge in sodium? Sodium, exactly, it is +1. There is no doubt, right? Sodium is +1, but hydrogen is -1 here. See, look at these two examples, So in this first example, water, hydrogen is +1, but this sodium hydride, hydrogen is -1. But why there is a difference? If you look at this, now sodium is not connected to electropositive metal, it is electronegative, compared to sodium, hydrogen is more electronegative. That is why it is +1 and this is -1. Metals, right? Metals are more electropositive. So when it connects with metal, hydrogen is -1. When it connects with non-metal, oxygen is non-metal, right? So hydrogen is +1. So very simple, hydrogen plus, if it is with metal, what is the charge? So charge is -1. But hydrogen with non-metal, so what is the charge here? With +1. So this is for hydrogen oxidation number. So like that, we have rules for oxygen, we have rules for nitrogen, we have rules for a particular group. Suppose halogen, if I say, what is halogen oxidation number? Normal oxidation numbers. Halogens, no? Do you know what is oxidation number of halogens? Sir, what are halogens? Fluorine, chlorine, bromine, iodine, all these are halogens, right? What is the meaning of halogen? Hydrogen. Gen means forming. Okay. Halogens are basically salt forming elements. Hydrogen, water forming element. So that is why the element name is given hydrogen. Gen means forming. Okay. Like that. Okay. Halogens are electronegative elements. Their charge is -1. Hydrogen charge, we just saw that, no? -1. It can be -1. It can be +1. So like that, we have different rules for each and every metal, each and every element. So we have a definite rules. So now look at this question. This question is not asking oxidation number, but still we discussed oxidation number because total redox reactions, in every question we should know oxidation number. Otherwise you can't balance it. So this is a redox reaction. But how do we know whether it is redox reaction? We should find out oxidation numbers. Okay, so let me find out oxidation number for this reaction. So what is there here? MnO4 minus. Okay, so there is MnO4 minus, C2O4 minus 2, H plus. So listen carefully, I'll give you very simple trick to balance redox reaction. You can apply to any other redox reaction. You can easily solve. Balancing redox reaction is our topic Focus on this. You can balance, after this concept, you can balance any other reaction, whether it is acidic medium, basic medium, any reaction, you can balance it easily. Okay, so I'm writing this reaction again. MnO4 minus plus C2O4 minus 2 plus H plus gives Mn plus 2 plus CO2 plus H2. This is our reaction. Okay, first let us find where is oxidation, where is reduction. Okay, so help me now, which is oxidation? Mn, oxidation number. So I'm taking X. Okay, X plus oxygen is -2. I'm just doing a simple maths because charge it is given -1. So sum of charges of these elements must be equal to -1. So oxygen charge is -2 into 4 is equal to -1. So X is equal to how much? +7. Mn is +7. Okay, we'll write now. Mn is how much? +7. So +7 to +2, right? +7 to +2. What is this here? Oxidation number decreased. So what is it? Tell me. Is it oxidation or reduction? It's reduction. What you're asking, can you show oxidation number explanation? We can take screenshot. Okay, one second. Oxidation number you're asking, right? See, look at this. It is hypothetical charge present on element when other elements removed as ions. Okay, just hypothetical charge. So look at this now. Look at this. So this is +7 to +2, right? This is what? Reduction. Okay, fine. But in every reaction, if there is reduction, there is always oxidation. There is no doubt, right? Now C2O4 minus 2. What is the another element? Carbon. Oxygen usually, 90%, 95% cases, or 99% you can take, 99% cases, oxygen doesn't change. But 1% case, oxygen can be changed, like peroxide, superoxide formation is there, then oxidation number can be changed. But in 99% cases, oxygen is just -2. So oxygen will not change. Okay, but carbon can be changed. What is other element? Carbon. So carbon oxidation number, can anybody tell me now? It is X, no? 2X plus -2 into 4 is equal to -2. So X is equal to +3. Yes. Am I clear? Yes, it is +3. Everyone is getting this right? So this is oxidation number of carbon, left side. Now what is oxidation number carbon, right side? It is +4. Why? So you can take it as X -2 for oxygen 2 times equal to 0, X equal to +4. Very simple, right? So +3 to +4. So increasing or decreasing? It is increasing. So what is it now? This is oxidation. We found reduction and oxidation. Yes, we confirmed. Okay, this is redox reaction. Okay. Now let me tell you one more thing. Reduction and oxidation, basically it is gaining and loss of electrons respectively. Reduction means it is gain of electrons. That is why you see this, no? Charge is decreased, oxidation number is decreased. So that is the meaning. It is gaining electrons. How many electrons are gained? +7 to +2. Electron charge is -1. So can you tell me how many electrons are gained? How many electrons? Sir, how do we find out how many electrons? Very simple. Subtract the charges. 7 minus 2. 7 minus 2. 5 electrons. Very simple. Exactly. No? So 5 electrons. Now I'll write it again. Okay. MnO4 minus plus C2O4 minus 2. I'll write electrons this time. We identified oxidation reduction in the first step. Now I'll write electrons. Okay, so how many electrons here? So there are 5 electrons. Okay, good, great. Now reduction, oxidation, +3 to +4. How many electrons here? For C2O4 -2, how many electrons? Can you tell me how many electrons now? Sir, it is very simple. 4 - 3. Is it like that? Acha. Now we should be careful. See, there are 2 carbons here. No, look at this. There are 2 carbons here, but here only 1 carbon, right? So first balance the atoms which are undergoing change. So what I'm doing is I'm just balancing this. Look at this. 2 carbons must be there. Now look at the change. There are 2 carbons. So on each carbon +3. Okay, fine. And each carbon +4 here. Okay. So look at the total electrons, no? Total charge is +6 here. Total charge is +8. So how do we get number of electrons here? 2 into +4 minus 2 into +3. Sir, why you multiply with 2? Because there's a carbon, no? Carbon. So 2 into +4, right side is more. So I've written first 2 into +4 minus 2 into +3. So that is how much? 2. Okay. Getting the point here? Exactly. Yes. Right. So now we have discussed very important step in balancing. See, so the next step, what I'll do is, so what I got here, I got 2 numbers here, basically the electrons, no, 2 numbers, 5 here, 2 here. Okay. Now what I'll do is, I'll just cross multiply these numbers. Sir, what are you talking about? What is cross multiplication? See, look at this carefully. Reduction, there are 5 electrons. Okay. Reduction, 5 electrons. Gain. So what I'll do, this 5 number, I'll multiply with oxidation. So let me write that, no? So you will get clarity about this. See, MnO4 minus plus C2O4 minus 2 plus H plus Mn plus 2 plus CO2 plus H2O. Okay. Now what I'm doing is, here already 2 is there, I'm writing 2. So 2. Fine. So what I'm telling you, 5 I'm multiplying here. So this is 5. 5 into 2. So what I should write here, 10 CO2. 5 into 2. 2 already there, no? So 2 is there, right? So 5 into 2, 10. Fine. So what about this number 2? 2 also you can multiply here. 2 multiply with reduction. 2 electrons loss, right? You're multiplying here. 5 electrons gain, right? You're multiplying with this oxidation. So this is what cross multiplication I'm talking about. Oxidation change you multiply with reduction. Reduction change you multiply with oxidation. This is the most crucial step in balancing. Okay, once more. Okay, fine. Listen carefully. So what I got here, 5 electrons, no, this is gain. Okay, 2 electrons, this is loss. Okay. Now in any reduction or oxidation, electrons must be balanced. Okay, electrons must be balanced. So what I'm doing for that is, the gain 5 electrons I'm multiplying with oxidation. That means I'm multiplying with this, no, 5, no, into 5. This is oxidation, I'm multiplying 5. But this is reduction, so I'm multiplying with this 2. Cross multiplication. Got it now? Just I did cross multiplication. I found oxidation and reduction. And next step, I found electrons, how many electrons gain, how many electrons loss. After that, I just did cross multiplication. Okay. Okay, so let me discuss one more thing. Next step. Okay, so here we cross multiplied. So look at this. I'll write the same reaction again, and we'll start with this here. Okay, this reaction I'll be writing again, and we'll balance. Okay, so 2MnO4 minus, yes, 2MnO4 minus plus 5C2O4 minus 2 plus H plus. This is giving us 2Mn plus 2 plus 10CO2 plus H2O. So this is what we got, right? Is it clear? So till this step we did. Till this step we did. Now what I'll do is one more thing. See, I'll balance the charge. Balance the charge. Left side and right side. Sir, how do we balance charge? See, look at the left side charge. No, what is the charge on left side? So let me write left side, LHS, left hand side of this arrow. No, what is the charge? Can anybody tell me now what is the charge on left side? Left side charge, no? -1. It is iron, right? MnO4 -1, but 2 times, no? So 2 into -1 plus 5 into -2 plus 1 into H plus. Okay. Or what you can do is you leave this, so then we can balance this H plus later. Okay. We can just balance this ones. Okay. Don't write H plus, we can add H plus later. Okay. LHS, what I did, 2 into -1, 5 into -2. How much it is? -2, -10. So -12. Okay. RHS, don't worry, we'll be adding H plus later. Okay. So now look at this. 2 into +2. So how much it is? +4. Okay. Now how do we balance charge? Here -12 +4. Sir, how do we balance charge? So very simple. We ignored H plus, right? You add H plus. But how many H plus I should add? So that both sides will get balanced. How many H plus? Shall I add +1 H plus? So how much I'll get? +1 H plus. H plus charge is 1, right? So -12. If I add only 1 plus 1, -11 only. But it should become +4. So how much I should add? How many H plus? Can anybody tell me now? How many H plus should add so that I'll get +4? Exactly plus 16. Yes, plus 16. Yes, no doubt. Okay, plus 16. Okay, so 2MnO4 minus plus 5C2O4 minus 2 plus 16H plus. Done. Now 2Mn plus 2 plus 10CO2. Sir, we have not balanced oxygens. Yes, I know. Okay. First, balance hydrogens. Very simple way you can automatically oxygens will get balanced. First, balance hydrogens. How we can balance hydrogens? The 16 H plus. No. How many H2 are there? How many hydrogens? 2 are there. Already 2 are present. So I'm multiplying with 8. Okay. Now oxygens, hydrogens, just check everything is getting balanced. Just check. This is final equation, right? Everything is balanced. Mn, you check, no? Oxygens, hydrogens, everything is getting balanced. Acha, already 1H, you are saying 515. That is fine. That's fine. This is fine. See, it is little bit tricky. Okay. So I'll repeat this because it's a very, very important to know balancing redox reactions. I'll repeat the process. No? Okay. See what we did first step. First step, no? See this? In the first step, we identified oxidation and reduction. Okay. Yes, oxidation reduction. And next, what we did? How many electrons involved in reduction? How many electrons involved in oxidation? Sir, what we got here? 5 gain, 2 loss. So you just cross multiply 5 electrons gain, right? You multiply this with oxidation. 2 electrons loss, multiply with reduction. So step by step, I'm going in detail, no, very slowly, because the many number of questions can be framed balancing redox reactions. It is that much important in chemistry. Okay, so cross multiplication is done. After that, what I did, balancing charge, I just balanced charge by using what? See, first I calculated charge left side, right side. Left side is -12, right side is +4. So we can balance this charge by using H plus. So do we use H plus always? This we can do in acidic medium only. So in redox reactions, it will be mentioned balance the reaction in acidic medium or balance the reaction in basic medium. Okay. Now this reaction in acidic medium, how do we know it is an acidic medium? Because H plus is mentioned, right? H plus is for acids. OH minus is for bases. If it would have been given basic medium, so we should use OH minus to balance charge. OH minus to balance charge. Okay. Done balancing. Everybody understood, I hope. Right? Yes. Okay. So we got the answer, right? So what is the answer? They're just asking coefficients. What is the correct option? Look at this. So we got coefficients, 2, 5. 2 for MnO4 minus, 5 for C2O4, 16H plus. 2 for MnO4 minus, 5 for C2O4 minus 2. This option B. Okay. Done. Everything is clear, right? So we'll move on to the next question, right? Right, exactly, B. Next question. Now, see this question. Hot concentrated sulfuric acid is moderately strong oxidizing agent. Okay, great. They are giving a hint. No, what they are saying? H2SO4 is oxidizing agent. That's great. No? Oxidizing agent. Now, in the last example, what is oxidizing agent? How do we find? Let us go back to the last example, last question, what we did, and what is oxidizing agent? So you should get clarity about this, no? Oxidizing agent. Okay, so look at these two. Look at these two. I'm highlighting these two. So look at these two. Which one is oxidizing? Is it green or is it pink one? Which one is oxidizing agent? Green or pink? Green is oxidizing agent. Why is that? Yes, Shravya, they will question in the question itself. No, it will be mentioned whether it is acidic medium or basic medium. Okay, fine. Okay, listen. Green, because this is oxidizing agent, no doubt. Okay, why? Because oxidizing agent will oxidize other species. It is oxidizing carbon. Look at this. See, MnO4 minus is oxidizing carbon. Carbon is going from +3 to +4. Yes. Now this one is reducing agent. What is the role of C2O4 minus 2 here? This is reducing, no? Reducing Mn. So see this. Mn is going from +7 to +2. Exactly, right? So this is oxidizing agent. This is reducing agent. Sir, how do we find out? See, if it undergoes reduction, it is oxidizing agent. If it undergoes oxidation, it is reducing agent. Itself, no? MnO4 minus itself, it is undergoing reduction. So it is oxidizing agent. C2O4 minus 2 itself undergoing oxidation. So opposite, it is reducing agent. So let me write clearly. So if it is oxidizing agent, okay, if it is oxidizing agent, oxidizing agent, no, involves in opposite reaction. What is opposite reaction? Reduction, right? So involves in reduction reaction. Okay. Now reducing agent means what? What is reducing agent? So this involves in oxidation reaction. Clear? What we need to do here? They are saying which of the following reaction does not show oxidizing behavior. So H2SO4, which element is getting changed? H2SO4. So most probable you have to search, no? Hydrogen, no. Usually, no. Oxygen, usually, no. Only sulfur. So let us check sulfur. So if sulfur is undergoing reduction, that means it is oxidizing agent. So I'll write it. Okay. H2SO4 is oxidizing agent. It behaves as oxidizing agent when it is possible, when sulfur undergoes reduction. I mean, just look at sulfur. So in which reaction it is undergoing reduction, that means it is oxidizing agent. Okay. So what is the correct answer for this? Donates O2. Achha? No, sulfur. Look at the oxidation numbers properly. Okay. No? CaSO4 plus HF. Okay. I've given all possibilities. Just check. Which case it is not showing oxidizing behavior. Let us see option A. Option A. Option A. See this. Left side it is plus 6, no doubt. Right side it is plus 4. Again, plus 6 to plus 4. So it is undergoing reduction of sulfur. So it is fine. It is oxidizing agent. So same here. It is plus 6. Again H2SO4 and again same. So plus 6 to plus 4. Yes, it is also oxidizing agent. See, it is oxidizing sulfur. It is oxidizing copper. Now see this. Same plus 6 to plus 4. Yes, here also it is oxidizing agent. Now see this one. There is no sulfur dioxide. No? So plus 6 here, again plus 6. So plus 6 to plus 6. So this is not showing oxidizing behavior. So option D. Getting the point, right? Sulfur oxidation number is not changing. So H2SO4 is not oxidizing agent in this. Clear? So what you can remember is very simple way. So this is also experimental. H2SO4 gives SO2. That means H2SO4 is good oxidizing agent. So if it is oxidizing agent, what H2SO4 will do? It will liberate sulfur dioxide gas in any reaction. So you should remember like this, no? In any reaction, if H2SO4 is oxidizing agent, it will liberate sulfur dioxide. Okay, got clarity? Acha, different name for this you are asking. Okay. See, what is happening in this reaction? This is not redox, no doubt, right? There is no change in oxidation number. Then what is it? Their ions exchange, right? Ions are getting exchanged. Fluorine is going with H, calcium is going with SO4. So what is this now? Ion exchange reaction, displacement we say. Okay, double displacement because two ions are exchanged, right? Calcium SO4, H with F, fluorine. Okay, it is like double displacement type. There is no reduction. Okay, right. Shall we move on to the next question now? Okay, this question. See this question from hydrogen and its compounds. Look at this carefully. Look at this carefully. No? At its melting point, ice is lighter than water. Just read this options. I'll tell you. I'll get back to you. Okay. First, read the options carefully. So this is conceptual question. Please read the options. So you should get clarity about ice and water. So, at its melting point, ice is lighter than water. What is the reason? So I'm getting different answers here. Huh? So A, B. Read the options carefully. Okay. Read the options carefully. See, unique behavior of water it is. Okay. So there is unique behavior. I'll tell you what is it. Okay. See, first let me discuss. No, H2O has hydrogen bonding, no doubt. Okay, H2O has hydrogen bonding. Sir, what is hydrogen bond? What is hydrogen bond? Anybody knows? No, everybody knows, right? What exactly hydrogen bond? So most important molecular attraction it is. No, see this red dotted line, dash line is hydrogen bond, but the blue one is covalent bond. It is between atoms. Covalent bond is between atoms, but see this bond, it is not between atoms. No, it is between molecule. See, H2O is molecule, not an atom, right? H2O. So there is another H2O. Okay, now this hydrogen of one molecule is attracted to oxygen of another molecule. So this is basically hydrogen bond. Okay, so listen carefully now. Sir, hydrogen bonding is only for water? No, no. Hydrogen bonding is possible for three elements. Hydrogen definitely has to be there. Yes, no doubt. And remember this trick, no? Phone, not mobile phone. Okay. FON. So F for fluorine. Okay. O for oxygen. N for nitrogen. They are topmost, no? They are three toppers, top three rankers in periodic table. On what basis? Electronegativity. Okay, so they are the most electronegative elements. This is basically electronegativity order. F highest, no, next oxygen, next nitrogen. Okay, and listen carefully. Now coming back to water now. So hydrogen bond means what? Hydrogen bond, hydrogen is connected to oxygen or fluorine or nitrogen of other molecule or other group of molecule, other part of molecule. So that is called hydrogen bond. So water shows strong hydrogen bond. So no doubt water shows hydrogen bond. But water has different forms, right? Vapor phase, it has liquid phase, solid phase. Now, if you discuss ice and liquid water, so there is a small difference. In ice, listen carefully, in ice, for each water molecule, each H2O, there are three hydrogen bonds. Okay, but for each H2O, there are four hydrogen bonds in liquid water. So that's the main difference between ice and liquid water. Ice and liquid water, main difference is what? Number of hydrogen bonds, no? Number of hydrogen bonds. See this? Each water molecule is bonded to three other water molecules. Yes, Samriddhi, H is directly attached to fluorine. Okay. Fluorine of other molecule or fluorine of other part of molecule. See, if I write, no, this one, H, sorry, if I write this HF and there is HF. Now this red color I'll show. This red color one only hydrogen bond, not the blue bond. Blue bond is what? This is covalent, no? This is covalent. This is hydrogen. This is minus, this is plus. See this bond, red color bond between molecules. This is one molecule, this is another molecule, between molecule. That is hydrogen bond. And look at this. Crystalline form of water is ice, no doubt. Crystal form, solid form. At atmospheric pressure, what will happen? See, this ice has hexagonal form. Because in solid state, solids have different crystal systems, right? In our nature, any solid can be classified into 7 crystal systems. CT or HMT, that trick, no? When we discuss solid state chapter, I'll discuss with you. There are 7 crystal systems for any solids. So ice has hexagonal form. Okay. At low temperature, what happens is, at low temperatures, it will turn into ice gets no cubic form. See, these are different forms of a solid. The arrangement is different. Hexagonal form, cubic form, the different forms. Okay, so now listen carefully. Why I'm discussing all this? Because see, for all substances, any matter, no, any kind of element you can take, any kind of compound you can take, solids and liquids. Okay, so density of solids, no, usually more than density of liquids. This is true. Yes or no? Density of solids, no, it is more than density of solid. Listen carefully. Density of solid is more. What is density? Mass per unit volume, right? So solids means particles are closer. So definitely solids density is more than liquid density. But listen carefully. For water, density of ice is less than density of water. See, water is completely different. Usually solids are more denser, no? More mass is concentrated per unit volume. But see here, ice has less density. Look at this bonding, no? Ice has 3 hydrogen bonds only. Means per unit volume, if you compare, no, more empty spaces in ice. More empty spaces in ice. But see this, there are 4 hydrogen bonds. What are bonds? Bonds basically attractions, right? If attractions are more, molecules come closer. But see here, there are 3 attractions, you can say. 3 water molecules are attracted, but here 4. So where attractions are stronger? Liquid water, more attractions. So liquid water has more mass per unit volume. So that is why ice floats on water, liquid water. Okay. So these are the very, very important points about liquid water. Now get back to this question. No? So what is happening here? Ice is lighter than water. Yes, no doubt. That is what we discussed here. Because first point, H2O molecules are more closely packed in solid state. No. Is that true? If they are more closely packed, no, density should be more. Yes or no? But density is less. Acha, how in liquid water it has 4 hydrogen bonds? That is, I'll explain. One of the student is asking, no, Sir, how it is showing 4 hydrogen bonds? I'll discuss this. See this, look at this. This is water, okay? And there is hydrogen bond here in liquid state. There is hydrogen bond, and see this, 2 hydrogen bonds with this oxygen. This is like tetrahedral arrangement. So experimentally it is proved, no? So there are 4 water molecules. You see this HOH, HOH, HOH. Every H is connected to oxygen. So make sure you should write oxygen here. Okay. So this way, so that tetrahedral arrangement. So there are 4 hydrogen bonds. Okay. Fine. So look at statements. No. So first statement is wrong. Yes or no? This is wrong, no doubt. Because if they're closely packed, no, that solid should have more density. Next, ice crystals have hollow hexagonal arrangement of H2O. Okay. Is it true? Yes, somewhat true. Okay. Ice crystals have hexagonal arrangement. That is what solid state structure, no? Because solid state can be like cubic, tetragonal, orthorhombic. So hexagonal is one of the form. Yes. Next, on melting of ice, H2O molecules shrink in size. No, not at all correct. Ice forms mostly heavy water. No, this is not related. So obviously this one. This has hexagonal arrangement. So that will give no more space between the molecules. Less mass, more space. Getting the point, right? Less mass, more space. So that is how no it has hexagonal arrangement, density is less, so ice floats on water. Okay, understood each and every point here. So these are very important point in water, ice. How many hydrogen bonds, why it is less denser, because more spaces, less attractions, more spaces. Okay, next question. Okay, time is over, fine. Okay, so last question. Okay, last question. So we're done with today's class. Okay, sorry I came late, so that is why I'm extending. Otherwise I could have finished, no, at 7:45 only. Fine. So last question, so we can end the session. See, look at this. Match the following. Temporary hardness of water, everybody should know. Temporary hardness because of bicarbonates, right? Uses of this is because of bicarbonates, calcium and magnesium. If these bicarbonates are present in water, that water has temporary hardness. So B must be 1. Achha, now over. So we're done with this question, right? Acha, why it is not with sulfates? I'll tell you. Temporary hardness means it can be easily removed. See, if you heat this bicarbonates, no, if you heat this bicarbonates, what will happen? You will get carbonate. Okay, so as simple as that. So temporary means you can easily remove by just heating, no, you can convert into carbonates. So carbonates are precipitates. By filtration, you can remove this. Okay. So that's why it is temporary hardness. Permanent means you can't remove sulfates. You can't remove chlorides. See, look at this. Permanent hardness means permanent hardness. You can't remove easily. You can't remove just by heating. So this is because chlorides and sulfates of calcium, magnesium. If these are present, that is permanent hardness. That water has permanent hardness. So very simple. B is 1. I think this only with this, only with 1. Yes, we'll continue. Okay, fine. Fine. Listen carefully. So temporary hardness because of bicarbonate. B is one. Yes, B is one. There is only one option. It is matching with this, right? And CO plus H2. This is called water gas, synthesis gas, syn gas. We say it. It is a very good fuel. Syn gas, water gas. What is it? It's a fuel. Carbon monoxide plus H2. Okay. So A is 3. So first option is correct, no? C is 2. Electron deficient means octet is not completed. Octet is not complete. I think yesterday we discussed, when we discussed Lewis acid, last class, no? Lewis acid, electron deficient. H2O2. So this is non-planar, like open book. This is on one paper, no? You open the book, no? So this is like this. This is an other paper. Open book structure. Okay, so thank you everyone. So we are done with today's session. Thank you very much. So I hope everybody liked the class and you have learned balancing redox reactions and ice, water, all these concepts. So please share your feedback. Okay. Thank you. Thank you. Actually, Samruddhi, Sarvi, everyone. Thank you. Thank you. Permanent hardness notes. Acha. Okay. See this. Chlorides and sulfates of calcium and magnesium. Calcium chloride is present, calcium sulfate is present, or magnesium chloride, magnesium sulfate. These will cause permanent hardness. You can't remove by just heating. Okay. Acha, how permanent hardness is removed? Fine, but Ganesh, no. So we have discussed a very important concept in detail. We can use different methods like Calgon's method, ion exchange resin. Okay, sure. We'll send this PDF. Okay. Thank you. Okay, thank you guys. Okay, so we'll meet in the next class. So we are ending the session. Okay, fine. Please take care of yourself. Don't go outside and wear mask. Okay, bye. Thank you.